Yeah. So according to started. So yeah. So from week 1 to 8, it will be like a similar question kind of like PNG. If you watched all the lectures and if you solve all the practice 7 question and graded 7 question, it will be easy for you. So it will be like from the lecture and from the assignment itself. And from 9 to 12, it will be like MCQ question. Like there will be 5 to 6 MCQ question will be there. And you can, if you solve the program assignment, you can easily solve it. And yeah, so that's it. And we'll solve some questions. So Umya Lakshmi, can you please do it?
For from week 9 to 12, it will be theory questions or some numerical also can be asked.
It will be MCQ question, like theoretical. Like if you solve the programming, it will be like very easy. Like
Okay, okay.
yeah.
So week 9 is like there's the algorithm for that. So that is also like we can expect some questions around that also.
1 or 2 question MCQ you may expect, or maybe numerical, but it will be very easy, like from the lecture itself.
Okay.
You are on mute if you are speaking. Can't hear.
Yeah, Umya Lakshmi.
Yeah, am I audible? All right. I have shared my screen, people. Can you all able to see my screen?
Yes.
Yes. Yeah.
All right. Then we'll start with the discussion, people. The first question is, in a congested network. Yeah. So the first question is, in a congested network, a ping test from Chennai to Delhi gives the RTT values ranging from 41 to 1128 ms. So if the mean is 167 ms, what is the maximum observed deviation in the like from the mean? That is what is the question. Okay. So here, what will be the answer, people? So minimum they have given us 41 and maximum they have given us 1128 and the mean is 167. So what will be the answer then?
Maximum minus average to mean.
Yes, that is the mean. So which means like 1128 minus 167 I have to subtract, right?
Hmm.
So in subtracting 100. Yeah. So 1128. I'm subtracting it with the 167. Oops, sorry, my writings are visible, people?
Uh, I can see couple of lines only.
Okay, I'll just write again. How about now?
Yeah, it is visible.
Okay, 1128 minus 167. So what will be the answer we'll get? So it will be of 961. Okay. So that will be the answer here as well. And the next question is, which of the following is not a typical reason for the packet loss in the network? So the options are congestion at the router, bit errors to noise, and buffer overflow, and then duplicate IP addresses. What will be the answer here?
So the following are typical reason.
Yeah.
Bit
So
error. Bit error due to noise.
see, which is not the reason for the packet loss.
Hmm. Yeah, duplicate IP address is correct.
See, if there is a congestion at the router, there will be a packet loss, and there is a like
Bit error, then that is also a loss.
yeah,
The
if there is
packet
a
will be discarded.
yeah. So the question is not a reason for the packet loss, which means
Duplicate IP address.
duplicate IP addresses. So here the answer will be this one. Okay. All right. So here is the next question, people. So a web server receives a 600 requests per second. Each request spends an average of 0.2 seconds in the system. On average, how many requests are in the system at any given moment?
So we will apply Little's law.
Yes,
So
we have to apply Little's law. What is Little's law?
L is equal to A into W. So
That is
A here,
to the average time in the system. So here, what is the arrival time?
arrival time is
600.
600. Yeah, 600.
Yes, yes, yes. So here the arrival time is of
600. And average time is 0.2 seconds.
and the average is 0.2. So what will be the answer then?
120.
Yes. So what will be the answer then?
120.
120 will be the answer. 120 is nothing the answer. Okay. So the next question is a fiber optic link is 45 kilometer long. If the signal propagation speed in the fiber is 2 into 10 to the power of 8 meter per second. So what is the propagation delay for one bit to travel from one end to the another end? They have also mentioned we have to write only in the like seconds,
Microseconds.
microseconds. Yeah.
So it will be distance divided by speed.
Yes, distance divided by the propagation speed. So what is the distance here?
45 kilometers. So we
So
convert into meters.
exactly, we have to convert into the meters because meter per second was the speed one. So that we'll get it in the seconds. So if I convert 45 kilometer, what will be the answer?
45 into 10 to power 3.
Which means 45,000 divided by 2 into 10 to the power of 8. Then, so 45 divided by 2 will get it as 2.25, right? Yeah. So 2.25, let's say.
In 200 for
Yes.
converting into microseconds.
Yeah. And also we have 10 to the power of 8 in the below and 10 to the power of 3 in the above. So we'll get it around 10 to the power of minus 5, right? We want it as minus 6. Sorry, we want it in the power of like already we have 10 to the power of 4, right? 2.25 in this into 10 to the power of 4. I mean like minus 4. Now we have to convert it into the minus 6. So we have to multiply into 100 and so that we'll get minus 6, right? So which means 225 will be the answer, right?
All right. Yeah.
Okay.
225.
So here is the next question. So consider the 16-bit words. So they have given some values here. That is 0x triple 4's and then 4 ones. So what we need to do here, after performing the checksum steps, first we have to add everything. Then we have to fold the overflow, which means whatever is the extra bit, we have to add it to it. And then we have to take the ones complement. So first thing is we have to add it, right? That is first value is 0x all a's. All a plus 1, what will happen? All ones. We'll get all the values as.
All these.
Then we have to add 2 to it. Then
All these.
we'll get all these. Then after that, we have to add all f's to it. Then
All C's.
no.
No,
First
all
we
these.
will
All
see.
these.
Then all will get it as carry, right?
Yeah.
So
So D and F
first
would
we'll
be
C. Then we'll
D.
get all carry. So we'll get D,
Carry.
D,
Yeah.
D,
Correct.
and 1 will get. Okay. So now with this 1 DDDC, I have to add 1 to it. So what will happen? 1.
1 D D D D.
Yeah. Okay. So this is the overall sum. Now I have to add the overflow, which means we have to add 1 to it. So what will happen? We'll get
DB, DE.
okay. So now we have to take the ones complement to this. So what is the
Yeah.
ones complement of this?
F minus this.
Yeah, we have to subtract with the all f's. So what will be the value then? So to reach f from E, we'll need 1. For the d's, we need 2's. So 2, 2, 2, 1 will be the answer here. Is it clear, everyone?
Yes, it's clear, ma'am.
Okay, so here comes the next question. If the bandwidth delay product BDP is for channel is 500 KB, so what should be the what should be the window size required to fully utilize the link? So assuming that the each packet has a size of 1 KB, then
Window size into packet size would be BDP.
yes. So for BDP, let's say window size is equal to, here we need to find the window size, right?
The window size is
BDP
uh,
divided by the
yeah,
packet size. Just we are taking it towards the equal, that's it. Okay.
yeah,
So what
BDP is given, so we can find it.
Mhm. So BDP is given here, and this packet size is also given. We have to find the window size. So it will be like
500
V
divided by
by
1
the packet size,
packet size
which means 500.
by 1.
Yeah, that's it. So which is nothing but the 500 is the answer here. And here is the next question. A channel has a bandwidth delay product BP. So here also BDP is given of 800 KB, and the if the required window size of the fully utilized link is 400. So what is the packet size?
So that will be BDP divided by window size.
Yeah. So here the same formula in the ulta way. That's it. So packet size is equal to
BDP by WS.
yes. That's it. Okay. So here I have to take 800 divided by 400. So what will be the value? 2. So here is the next question. TCP sender has a congestion window of 12 KB and a RTT of 60 ms. So assume each packet is 1 KB. So what is the sender's data rate in kbps? How to find the sender's rate? Data rate is equal to the
Congestion window divided by RTT.
RTT. Yes, perfect. So here what I need to do is the rate, right?
Yeah,
Which means 12 divided by, I have to use that formula, that is 12 divided by 60.
60 ms.
Huh.
So we have to convert it into second then.
Yeah. So let's say we are just keeping it as okay. So 60 ms has to be converted to the seconds first. So for seconds, we'll get it as 0.
Uh, 0.
0.06.
0.06, correct.
Yes.
And 12 kb also has to be converted into bits, right?
Yeah. First, let's divide it and then we can change it also, right?
Okay.
So
So
here
this
we'll
will
get
be
it.
200.
Huh. So then what I need to do, I have to convert it into the
Bits.
bits. So what I have to do into,
8.
yeah, that's it. So 1600 will be the answer here. And what is the
Ma'am,
impact of, yeah?
one question I had. Here, the packet size does not matter, right? So whatever the packet size is, the answer is still congestion window divided by RTT, right?
Hmm.
In the above question.
Yeah, that is true.
Yeah.
Okay.
Because
Okay.
here data rate is equal to congestion window divided by the RTT. That's it. So we are going to apply that formula,
Yeah.
Bas,
Yeah.
irrespective of that. Okay. So here the next question is, what is the impact of keeping the receiver's packets of receiver socket buffer too small?
What is the impact? So it limits the sender's throughput and reduces channel utilization. That is true. It
Mm.
increases round trip latency. That is not true. It causes checksum error. Not true. It increases TCP connection setup time. Not true. The first
Yes.
one is correct.
So if the receiver's socket buffer is too small, what will happen? The receiver window becomes small, right?
So it will affect the throughput. Correct.
Exactly. So even if the network can handle, but the window size, of course, it's too small, so I cannot be able to handle it, right? So they cannot be able to completely utilize the available bandwidth. So here the answer will be, it limits the sender's packet, sender's throughput, and it limits the sender's throughput and reduces the channel utilization. Okay. And here is the next question. What is the primary purpose of gain cycling in TCP BRR? Sorry, BBR.
Doctor lost to probe network for additional available capacity to use one. Primary purpose is to probe the network for additional available capacity.
Okay. So generally this TCP BBR, it uses the gain cycling. So what it will do, it like every now and then, like just periodically it varies the like sending rate. It will be like above and below, right? Above and below the like what is that estimated bottleneck bandwidth. Okay, which means if there is a more bandwidth available, what will happen?
In BVR, as I know that it increases, it works on additive increase. So every time it
Hmm.
adds one MSS.
Yeah. So it's like it is to probe the network for the additional available capacity will be the right answer here. Okay. And the next question is, in TCP Reno, the fast retransmit mechanism is triggered when?
When three duplicates acknowledged and received.
Yeah, because the fast retransmit, it should be like whenever the sender receives the 3 duplicate acknowledges for the same packet, that is
Yeah,
where it will just say it's a packet loss, right?
correct.
So here, this will be the answer, of course. And yeah, next question is, sorry. A network has been assigned a address block of 192.168.8.0 divided like by 25. Okay. So how many usable host addresses can be assigned to devices in this network? They're asking
That,
about the usable. So
so
for
that,
first we need the subnet size, right?
yeah.
So how many will be that like that they have mentioned is 25 bits for the network, which means 32 it can
So
handle. So
7 will be there for host.
yes.
So the
So
total
we'll
will be
do
2 to the power
32
7.
minus 25 is 7. So what is 2 to the power of 7? 2 to the power of 4 to the right?
128, I believe.
Yeah. So we'll get the value is 2 to the power of 7 is 128.
128.
Yeah.
Yeah.
We'll get the value is 128. Then what we need to do? We need the usable host.
So we will minus 2
Yes. Why 2? We have to
for the
subtract.
local.
That is the network and the broadcast addresses
Correct.
we have to remove.
Correct.
So on removing it, we'll get it the value as 126. That will be the answer for this. Okay, here is the next question. A packet is sent with TTL of 64 and reaches the destination with TTL of 57. So how many routers did they pass through?
The difference
Yeah.
in
So what
these
is the
two.
difference here? Like initial is time to live is 64. At the destination, it's 57, which means the difference is of 64 minus 57, nothing but 7 will be the answer here. And organization has 1200 devices connected in a private network. Each NAT router can handle up to 60,000 simultaneous connections and can serve 250 devices comfortably. So if they use NAT, one public IP per NAT router, so how many public IP addresses are required? So what we need to do? So number of devices per NAT is what?
Number of devices per NAT is 250.
Yes. What is the total number of devices?
So total number of devices 1200.
So what will be the answer then? So for total routers, we need only two datas, right? One is total number of
Number
devices
of devices and how many devices it can serve. So
do at that time. So on dividing it, what will be the value?
it will be 4.8,
8, right?
yeah, 8.
So can I give the public address like 4.8 and all? Number of public IP address required is 4.8. Can we give it like that?
No.
It has to be an integer value, right?
Yeah.
So I can give the value as 5 because which is the nearest value. Okay. If your phone and laptop both show the same IP address when checked on what is my IP.com. So what does this imply?
They are behind the same NAT gateway.
Yes. So when the multiple devices in the private network access the internet, then NAT, that is the network address translation, what it will do, it translates the private IP to a single public IP addresses. Okay, that's why when I'm checking the IP addresses, it will look like a same one. Is it clear, people? Okay. So we have discussed around 15 questions, like on an average of each week I have just taken around 2 questions. Okay. So this is how this intern will also be, people. Mostly it will be like numerical type questions and few will be like MCQs.
But is there any question have you picked in this slide from week 10 to 12?
No. It is like I have just taken only from GAPS. Like for week 9, 10, 11 and all, it will be like based on the understanding. Because why I didn't pick is there you have did like a programming assignments, right? Which means you would have understand that clearly. So that's why I didn't take any questions from there.
Yeah, that is correct. But just wanted to see the pattern.
As I
Okay,
mentioned,
anyways.
If you give one example, no, that will be like really helpful to see
Correct.
what kind of questions we can expect.
okay. So let's say in week wait. Okay, in week 9, what are the topics were discussed? It's like DV, like distance vector routing and Dijistra's algorithm, no? So, which means they would have asked about Dijistra's algorithm, like how to find, like what it is used for, something of that sort.
There is Bellman-Ford algorithm as well. So can we expect questions from that?
Like whatever is discussed, you will get questions from that.
Okay.
I cannot specify which algorithm and all, like
So
whatever.
basically, only 2 algorithms were there.
Mm-hmm.
So Dijkstra and Bellman-Ford. But I
Mm.
think GAPA Bellman-Ford question was not there. Only Dijkstra question was there.
Yeah, that's why
week
I'm.
9 did not have a GA, right?
Yeah, so that's why I said there was some question on Dijkstra, I believe. No?
Yes, Dijkstra's was in I think week 8, so we had questions there, but in
Correct,
week
correct.
9, yeah.
Bellman-Ford, we didn't had any question. So that's why I asked whether that is included or not.
See, like whatever included in the lecture, you can expect questions from that. Okay.
Okay.
So, for example, I have mentioned like Digistra's hands-on is there, so it might be something of that sort I have mentioned. I'm not saying like only from this algorithm or that algorithm. Okay.
Yeah, and
Okay.
in terms of code, ma'am, like, do we need to sort of remember what signatures like certain functions will have, what parameters they accept or something?
No, 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 no.
Okay, okay.
Yeah, okay. That's right. So, yeah, that's it, people. So, can we wind up the session then?
Yes, ma'am, I
Yeah.
think that's.
Yeah, okay. All the best for your intern, people. Bye bye.
Thank you. Bye bye.
Thank you, ma'am.